Okay, let's answer number 26 from the week 1 study guide. So question 26 from week 1 says the following. You throw a golf ball off the top of a building that's 14 meters above the ground. The ball is initially thrown 12 meters per second horizontally. A, how long does it take for the ball to hit the ground? And B, how far away from the base of the building does the ball hit the ground? So in this question, like just about any other question you do, you want to sketch out the problem and you want to write down everything that's given to you. So in this question, we are given a building which is 14 meters high. We're told that a golf ball is being thrown from this building, and as it's thrown from this building, it's moving in the horizontal direction at 12 meters per second. Now, during this time of flight, it's also falling. And so here's our nice projectile motion. Now, this isn't given to us, but we know it. It's going to be falling at gravity. And gravity, G, is 9.8 meters per second squared. So we've got a ball flying in the horizontal at 12 meters per second. We've got a ball flying toward the ground at the rate of gravity, which is 9.8 meters per second squared. And so what the question is asking us is, A, how long does it take, the time, for the ball to hit the ground? And then B, how far has the ball traveled in this horizontal direction away from the building? So this is the problem. This is how we've laid it out. And we've written down everything that was given to us. And so let's do this. A, we want to know time to get to the ground. Time to get to the ground. Question mark. Well, let's put down our simple formula for distance. We know that distance equals velocity times time. Okay, now you might be thinking to yourself, cool, I've got distance equals velocity times time. If I want to solve for time, then I'll just rearrange this equation and time is going to equal distance over velocity. The problem is we actually don't have a velocity yet. The velocity that was given to us is 12 meters per second, but that's the velocity of motion in the horizontal direction, not in the vertical. In the vertical, we know that the ball is accelerating downward at a rate of 9.8 meters per second squared, but we don't know what its velocity is. Now keep in mind, when the ball starts, the initial velocity going downward is 0 meters per second, right? It starts off at rest, then the ball is thrown, then it starts to fall toward the earth at 9.8 meters per second squared. What we really need to know is what that final velocity is. The vertical final velocity, that's what we need. And once we know that, then we're going to be able to solve this problem for time. Okay, now here's the challenge though. We actually don't want just the vertical final velocity. We want the average velocity. Because remember, the ball is starting at 0. It's ending at something much faster. We don't want the very fast one. We don't want its maximum velocity because that's not going to give us the proper time because the ball isn't constantly traveling at that same velocity. So we need an average velocity. We start at 0. We end at something bigger. The average velocity is somewhere in the middle. And once we have the average velocity, then we will have a better grasp at determining time. All right. Now with that said, this equation is going to become d equals whatever the final velocity is plus the initial velocity divided by 2. And now we multiply that by time. Now let's make this very easy for us. We know that initial velocity equals 0. So when we start to rewrite this equation, we're going to get rid of initial velocity because we know that that's 0. And our average velocity is just going to be the final velocity divided by 2. Okay, now if this were the end of the story, that would be great. But again, it's not the end of the story. And it's not the end of the story because we still don't know what the final velocity is. The final velocity is going to have something to do with gravity, right? That's the only way we'll be able to determine what this final velocity is. So there's another expression for time. that we need to consider. Time of travel is going to be the change of velocity over the rate of fall, which is gravity. And remember, change of velocity is simply whatever the final velocity is minus whatever the initial velocity was. And we know again that VI equals 0. Now you might be questioning to yourself, well, how in the world is time a change of velocity over gravity? You don't necessarily need formulas to figure this out. You just need to know units. Keep in mind that velocity is meters per second, and gravity or acceleration is meters per second squared. And so if we do meters per second divided by meters per second squared, meters cancel. We're left with s squared over s, and that equals s, or seconds. So we know that time is measured as a change of velocity over gravity. And so with this in mind, we can change this d formula to the following. D equals final velocity plus initial velocity over 2 times t. But remember, t is now this. So times change of velocity, which is Vf minus Vi over gravity. This is our new expression, but we're going to make it even better because we're going to get rid of those VI's, because remember, Vi is 0. So this equals Vf final velocity over 2. Let's write that 2 better. Vf over 2 times Vf over gravity. So distance is final velocity squared over 2g. So now what we're going to do is solve this problem for v final. So remember, v final squared is d times 2g, which means that the final velocity equals the square root of d times 2g. Okay, so now we've got this information. It took us a little bit to get to, but with a little thinking, we were able to get to it. So now what we're going to do is just solve for final velocity. So final velocity equals the square root of d, which is 14 meters, times 2 times the rate of gravity, which is 9.8 meters per second squared. So this is going to be our expression for final velocity. And once you do all the math, you're going to get right around 16.57 meters per second. So when the ball hits the ground, it's hitting the ground at right around 16.57 meters per second. Now, we still need to figure out what the time of travel is, but now that we know what final velocity, we'll be able to figure it out, because now we can just use this equation right there. So let's start a new page, and keep in mind 16.57 meters per second. Let's do a new page here, and here we go. We've got final velocity equals 16.57 meters per second. We know that our distance traveled equals final velocity plus initial velocity over 2 times t. We want to solve this equation for t, but before we do that, again, we're going to get rid of Vi, because Vi equals 0 meters per second. So we'll just make this a little bit easy for ourselves. So now d equals Vf over 2 times t. That means t equals 2 times the distance over final velocity. So 2 times 14 meters over 16.57 meters per second, which means the time of travel is a lofty 1.69 seconds. Okay, please check my math to make sure I'm right. So this means that the golf ball is falling at the rate of gravity, starts at an initial velocity of 0, hits the ground at a velocity of 16.57 meters per second, We know that it's taken 1.69 seconds for that ball to travel that distance. So this is the answer to A. In terms of B, now B is pretty much a piece of cake. B, remember, is how far from the building does the ball hit the ground? So let's draw that picture again. Remember, we started here. Here's the ball. It's gone 14 meters. It was traveling in this direction at 12 meters per second. As it's falling in this projectile fashion, it's taken 1.69 seconds for the ball to hit the ground. So we know that the ball is traveling a total of 1.69 seconds. So we can just use our simple distance equation. Distance equals velocity times time. This is pretty simple. The velocity in the horizontal fashion, or the horizontal direction, is 12 meters per second. And the amount of time it's traveled before it hits the ground is 1.69 seconds. So now all we need to do is multiply 12 times 1.69, and we're going to get 20.28 meters. So that's the answer to letter B. So we've gone this way about 20 meters. And that's it. So that's how you solve this problem. The initial part, letter A, is clearly a little bit more complex than letter B. Just keep in mind that when you're doing these physics problems, you really have to think of everything. You sort of have to think your way through the problem and make sure that you can get through all of these different elements. Anyway, that's it. That's question number 26. What I suggest you do in terms of practice is just set up problems like this, and you can change the number. The question could be exactly the same, but the more problems you solve that look like this, the better at it you're going to get. And in fact, you can even do different types of problems. You can say, okay, if the initial velocity is not 0, maybe the initial velocity is 5 meters per second, maybe it's already traveling at a rate, in which case you can solve this problem again. And now that you've got a slight change in variables, what's your answer going to be? So just explore these different problems, make up problems on your own, and then I think this will start to become very easy for you, or at least easier. Okay, if you have any questions, please feel free to contact me. I'm happy to answer any questions that you might have. Okay, take care. Bye-bye.